Hey guys, Buildzoid here, and today we're going to be taking a look at all the modifications I've done to my RX 6900 XT Red Devil Ultimate that I bought with the support of my patrons and Teespring, and links in the description. And let's get to the modifications because yeah, I think that's what everybody's interested in if they're watching this video. So let's start on the front of the card. The sort of most, well, actually, I'm not sure that it's the most obvious one, but yeah, this is a mod I did. This basically just bridges the 12-volt power planes from the 8-pin power connectors together, and I did this after the input filtering inductors, not before them, right? Like this is before, this is after. So this side is actually connected to the VRM. This side goes to your power supply. So I did it after I did it on the VRM side. I don't really think that was necessary. The idea is to just share the input filtering capacitance between all of the power connectors a bit better. I'm not sure that it was actually effective. But the thing is, you can also get cards from ASRock does this from the factory. They just have all of their input inductors output into the same 12-volt power plane. And I think ASRock is the only ones that do that. Everybody else has split 12-volt power planes for their different power rails, but ASRock just sort of dumps all of it into one 12-volt power plane before all of the phases. And I think with a lower, if it weren't for the fact that I added a whole bunch of input filtering capacitance, this might have been more effective than it ended up being, because the idea is it would just share these input filtering capacitors between the 8-pin power connectors, because normally they're completely separate, right? Whereas with this, they're now connected into one group. But yeah, I'm not sure that necessarily makes much of a difference, because I did it at the same time as other modifications, and it was just kind of like, well, doesn't hurt anything, and ASRock does it, so I'll just kind of copy that. Anyway, so that's a thing I did. Not sure if it's worth doing. Now, what is worth doing, or at least probably is worth doing, because this isn't, a thing is, with a lot of the modifications that I've done to this card, I've done them at the same time as other modifications, and that makes it really hard to tell which of them caused the effect that I ended up measuring, that I ended up observing. So, when I measured the stock card, the memory VRM was pretty noisy. In fact, let me just check the old oscilloscope shot that I have for that. Let's just take a look at it. So yeah, this was the stock memory VRM. Yeah, that's trash. That's 120 millivolts peak to peak. That's a 2-phase memory VRM, and apparently this is the best they could do at power color. That is horrible. And this is what it looked like after I modified it. Except I did a whole bunch of mods at the same time. So yeah, now you can see we only have 70 millivolts peak to peak. So yeah, and I'm not sure which mix of capacitors did most of the work. Well, actually, it's probably the biggest ones. That's the thing is these 470 microfarad Panasonics, these things are just amazing. They're also really expensive and completely out of stock on DigiKey right now. But yeah, these are 470 microfarad SMD aluminum polymers, not tantalums, aluminum polymers. Very important difference, because the tantalums cost more and are less effective. And I've tested tantalums and aluminum polymers, and these things, per microfarad, these are way more effective. Now, on input filtering, it's a totally different story, because you just can't get large capacitance, high voltage aluminum polymers in this style of packaging. But you can get tantalums. So tantalums are perfectly fine on the 12-volt side of the VRM. But on the output, tantalums are kind of they're still better than through-hole capacitors, but that's not much of an achievement in my opinion. Anyway, so 470 microfarads, 2.5 volts. You don't need to use 2.5 volts. The memory rail, you're never really going to be setting it above 1.5 volts. Even if you have an EVC, you wouldn't be shoving more than 1.5 volts into your GDDR6. It doesn't even really scale with voltage. I don't know, maybe the 18 gigabits per second cards scale with voltage somewhat, but yeah, on my card, I've been up to 1.42 volts, and it really just doesn't seem to make much of a difference on the memory. And even then, it's you don't need 2.5 volt caps for that. In fact, if you're ASUS, you use 2 volt caps for 1.8 volts. They do that on their DDR4 motherboards. some of them. But yeah, so 2.5 volts is just kind of like, I just have these in 2.5 volts. You could totally use 2 volts. That would also be fine. And these are 3 milliohm ESR, which is like the lowest possible ESR you can get in this, like in this capacitance, this style of package, and this voltage range. And this is really good. This is the main reason these things are so freaking awesome as output filtering capacitors. I love those caps. They're amazing. Way more effective than any other capacitor type I've used. Maybe multi-layer ceramics might be more effective, but the thing is, in order to get 470 microfarads in multi-layer ceramics, you need a lot of them. Whereas one of these has a substantial amount of capacitance on its own, and so even just one of them will have a pretty, like, depending on what you're trying to filter, like how much power the rail is pulling, even just one of these will have a pretty substantial effect. Anyway, then I also added 2 more of them over here. This is a capacitor sandwich, so basically what I mean by that is there's 2 of them like this. And then you have the tabs, right? Like so. And then they're soldered together. And then you have the wires, you can see those. So then there's just wires hanging off like that, and that connects them to this capacitor. So, yeah, so for memory power, I added these 3 of these. And yeah, I'd say that's a big part of why there's now like 70 millivolts on the output of the memory rail instead of 120. Other than that, I also added a 22 micro. There's these guys. So these are 22 microfarads. Now, I said the 470 microfarad ones are out of stock on DigiKey. You can get 330s, and that should still be close. And oh, you can, well, yeah, you can get 330s. So I just get 330s instead. I don't think 140 microfarads is going to make that much of a difference here in this scenario. Also, if you feel like it, you can just, add extension wires over here and pop one over there. Maybe also another one. Well, no, there's a screw hole here, but you could certainly, like, if you're going to use 330s, you could just use 4 of them instead of just 3, right? And that'll get you roughly the same amount of total capacitance, and actually technically lower ESR effectively, because 4 capacitors in parallel is better than 3 capacitors in parallel, but I don't think that will be too much, I don't think that'll be too significant as an effect in this scenario. Anyway, so 22 microfarad 0603, and the reason why I jumped back to the fact that these aren't available is these aren't available at all. I can't get them from the same manufacturer that I got them from. I can't get them from other manufacturers either, at least not on DigiKey. I've not checked other sites, but yeah, on DigiKey, these are gone. And multi-layer ceramics were already in a bit of a shortage before the general electronics shortage that we have right now, but now they're gone, properly gone. Previously I could buy them. I'd have to change brands pretty regularly, but I could source them. Now it's nope, can't buy them, gone. And these are either 4 volt, I can't remember if I'm using 4 volts or 6.3 volt ones. It doesn't really matter too much. 4 volts is perfectly fine because we're talking about a memory rail. So this, at stock, it sits at 1.35 volts. And if you're overvolting it, you you don't really want to go above 1.45 or even 1.5. I don't see much reason to overvolt it, at least not on the memory chips that you get with regular 6900 XTs. I've not really seen much of a benefit from messing with that. Yeah, so 4 or 6.3 volts, and I use X6S temperature coefficient because those are up to 105 degrees Celsius, and 80. The thing is, you can get multi-layer ceramics rated for up to 85, up to 105, up to 125, and up to 150. Now, 125 and 150 is obviously better than up to 105. But they're also way more expensive, and you're not necessarily going to get them in the capacitance and size you want. Whereas 85 is 85 degrees Celsius is not that hot for a memory chip. So you don't really want to be using capacitors that have a worse temperature tolerance than the memory chips literally right next to said memory, literally right next to those capacitors. So that's why I'm using X6S. And not a lower temperature, a lower max operating temperature, because yeah, that's my main concern there, is just up to 105C. Added one over here as well, also one down here, 2 down here, 2 over here, and 2 more over here. So yeah, added all of those. And so that's what I did on the front for the memory filtering. And then Other than that, I also added these 22 microfarad 0603s over here, which that's the VDDCI rail. I added one also over here, which that's V-core, this one V-core, this one V-core. Is that VD? Yeah, that's VDDCI. Skip these because the memory chip is kind of in the way and I didn't feel like sticking my soldering iron that near it. Over here, 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 and here. And then here, 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 and here. And then I also did here, 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 here. Yeah, that's it. Also, you could put them sideways if you wanted to. Put more of them in this area. Actually, I kind of want to count them. So how many is this? So this is 6 over here. And then V-core on this side. Actually, I don't... This really... I'm not sure if I did that one. But, okay, wait. So we have 6 on this side. Because this is something I've been wondering about, is like, have I added 1,000 microfarads worth of ceramics to this yet? Because I think it might be close. 1, 2, 3, 4, 5, wait. Yeah, no. So 4, 8, 13? Yeah, 13. So 13. So that's 19 of them on the front. Yeah, 19 on the front. Okay. I'm not sure that these are actually significant, but I just want to keep track of it because I wasn't keeping track of it when I was adding them. So yeah, 19 for V-core. Also, the memory ones, I'd say you want to do those. The V-core ones, I'm not sure, but the memory ones, I'd do them. So I guess let's move on to the back and talk about, okay, actually, you know what? Let's just straight up, don't bother with this. Doesn't do anything. Literally do not bother. Well, yeah, don't bother with these. Completely pointless. I was bored. Well, a lot of this is a case of I was bored and I wondered, hey, would this lead to better memory overclock? Would this lead to better overclocking? The answer for these definitely don't do, like, these don't do anything, don't bother. I also added this to VDDCI. Didn't really achieve much of anything either. Which was surprising because the VDDCI rail is, like, awful. Like, it's even worse than the memory rail. Like, look at this. This is 140 millivolts. I mean, it's a single-phase VDDCI rail, and the VDDCI rail on AMD GPUs generally pulls way more power than, like, the memory rail does, or at least way more current, which is really weird that, like, the memory has 2 phases, but VDDCI has 1, and VDDCI does pull more current. Which I always just find that so wacky about AMD GPUs. Well, actually, no, because if you look at like a 290X, you actually have a VRM configuration that perfectly matches that. The 290X has a bigger VDDCI rail, like bigger VDDCI VRM than memory VRM. But then you look at a 6900 XT and it's like, why does the memory have 2 phases and VDDCI 1? Well, apparently having this mess for your VDDCI rail, and this is graphics test 2, like this is 2 different workloads. So this is graphics test 1, this is graphics test 2. And yeah, VDDCI is just super noisy. But apparently this is just fine, because adding extra capacitors to VDDCI did not further improve memory overclocking whatsoever. So yeah, that's kind of interesting that the VDDCI rail is completely, like, is tolerant of running, like, absolute garbage. Then again, it's, like, pretty frequent that, like, memory control, like... Well, yeah, I guess it makes sense. Like, I've messed around with, like, undervolting the memory controller, and honestly, you can push the memory controller voltage really low, and it'll still run, like, stable. So I guess the memory controller just doesn't really care. It has a very large operating voltage tolerance range, and so it doesn't matter if there's, like, 100 millivolts, 180 millivolts peak to peak going into the memory controller, because... It just doesn't care. It's like, well, as long as I'm getting more than 0.88 volts, I'll run. Which the peak to peak there actually works at, like, I think the stock... Do we have RMS? Oh yeah, we have RMS on this. Yeah, so, you know, RMS voltage is like 95 millivolts. Max voltage is 1.06. So if you subtract 200, that's 0.86, yeah, so you're getting like 0.86 volts minimum. Actually, not even, right? Like, that's... But anyway, so you're going to be getting, say, like more than 0.86 volts minimum, and you can undervolt the memory controller to like 0.86 on my card, and it still runs just fine. So the memory controller just doesn't care. Like, I'm guessing AMD's running it at somewhat higher voltage than is absolutely necessary for it to function. but at the same time, it also doesn't which is like, oh, that's not great for efficiency, but it doesn't pull enough power compared to the power draw of everything else on the card to really matter that, they need to. This is a big part of like why like a lot of people why like undervolting and undervolting is a thing is like every piece of like all GPUs will ship with some safety margin built in. And so yeah, the memory controller on these cards just has a huge safety margin relative to like the stock operating voltage, and it just doesn't care that VDDCI is a horrible mess. So yeah, cap modding VDDCI, you may as well not bother with that. But for the memory, what I did is I added 4 little 4.7 microfarad 0402 4 volt. Actually, these might be 6.3 volt. I can't remember. Either way, again, it doesn't matter. It's the same situation as on the front. 6.3 or 4 volt X6S multi-layer ceramics. And I added 4 of them per memory chip. So yeah, you can see there's more. I also added I ran out of these, so I had 2 left over, so I added 1 over here. And then I added so there's actually like 2 of them over there. Like this memory chip has 5, right? This chip has 5, but the other ones all have 4. So like we have there, right? There. You get the idea. And then again, we have 2 instead of just 1. Yeah, and so the combination of adding all of these little 4.7 microfarad multi-layer ceramics and then the stuff that I did on the front made it possible for the card to bench 2180 memory. So like all this and then all of these that I added, right? Those by the memory chips, not the ones in the vCore VRM, like the ones by the memory chips. So the combination of all that made it possible for my card to bench. Like actually, if I run it at low core clock, I can bench even 2200, kinda. 2190 works fine at lower core clocks, and then for like full out runs, I've been running 2180. My top scores with this card are all at 2180 memory. When I first got the card, it wouldn't really perform properly above like 2150. So that right there is like a 30 megahertz memory clock improvement, and I call that that's good. That's great in my book. So yeah, there's GPUs where I've seen much bigger improvements, but that is not bad. Like I'm not going to complain about 30 megahertz more memory clock. So is this worth doing? Not really, but if you're into competitive benchmarking, then kind of yes. So yeah, also I'm kind of wondering, like the thing is I ran out of these 4.7 microfarad caps. I'm kind of wondering if maybe putting going up to 8 per memory chip instead of just 4 per memory chip would bring further improvements. Because the thing is, there's a difference between like when I was measuring this with the oscilloscope, I was measuring from over here, right? Or like somewhere in this area. So pretty far away from the memory chips. And the thing is, the biggest switching noise you're going to see is directly behind the memory chips, which is why the memory chips have these little capacitors directly behind them. So I'm not sure if like maybe adding more 4.7 microfarad caps directly behind the memory chips would still bring further improvements, even if like doing anything over here doesn't do anything anymore. Yeah, so that's one thing I'm wondering about, but I can't buy any more of these, or at least like I might have to check a different supplier, but these are getting kind of hard to find right now. So yeah, I also added some 4.7 microfarad caps over here, which at this point was a waste of 4.7 microfarad caps because that did absolutely bloody nothing. So don't bother with this at all. Yeah, don't bother with that. I mean, I wasn't expecting it to do much of anything. I was this was more of a case of like, I wonder if it was physically possible for me to add like caps over here. And it's like, yeah, it's not fun to do, but it is doable. Also pointless. I should have just put those on the memory chips instead of over there. Anyway, other than that, big significant modifications I've done is, well, obviously the biggest capacitors that I've added, physically biggest, are these. And so what these are 16 volts, and these are from Panasonic. Are they? Yeah, they're from Panasonic. I keep getting this mixed up, like Panasonic and Samsung. For some reason, they're like, they want, like, in my head, they just, like, blend into one company for some reason, when it's like, one of them makes memory chips, and the other one makes capacitors. Those are not the same thing. But the thing, I guess it's just, they're both huge, like, random electronics companies, right? Where they just kind of make everything. Actually, Samsung's even a more extreme example of makes absolutely bloody everything. Um, Actually, I'm pretty sure you can get Samsung multi-layer ceramic capacitors, now that I think of it. Anyway, doesn't matter. So yeah, 16 volt, 270 microfarad, 8 milliohm ESR. And the big thing for me with these was getting them in a 6.3 millimeter diameter. You can get smaller ones, but they're super expensive, and the ESR sucks, and the capacitance sucks, and they're just awful. So 6.3 millimeters is like the smallest diameter where you can get a reasonable combination like a reasonable combination of specs without paying through the nose for them. And even with like terrible, like I think there's like a 4.8 millimeter or like 5 millimeter diameter through all capacitors. And the thing is, they either had like three times the ESR and not as much capacitance, if I remember correctly. So it was like, yeah, no, I'm not using that. Especially since they were like the same price, if not higher priced, because it's just such a, like 6.3 millimeter diameter is like a pretty normal diameter for like this is a really common capacitor size. But the 4.8 millimeter or whatever, like there's one size that's a bit like even smaller. That one's really rare, and so I guess it's just really expensive because nobody uses it. So yeah, anyway, but 6.3 millimeter, and the reason why I was focusing on like getting them reasonably sized is because I want to be able to put the back plate back on the card, even with all of the modifications in place. So anyway, and yeah, I added one. Well, like these are very easy to see, right? Like you can see all the ones I added. Now you don't need to add this many of them. When I first added these 16 volt capacitors to the input, so this is the input filtering. Oh well, like the input filter is distributed around the PCB, but a lot of the input filtering is right here. Okay, so I added these to the input filter of the VR, like of all of the power rails on this card. And when I initially added them, I didn't include this one. I didn't include these two. I didn't add those two. These because that screw hole right there, and this one because, oh yeah, this via over there. Yeah, that via over there freaked me out. But it turns out that's just attached to the same, like that via is the same thing as this capacitor, so that's fine. But yeah, so you don't need to bother with those. Like I added these, and they just didn't lead to any further improvement. And I'm not even certain that you have to add like, because on this side of the card we have 6 of these, and on this side of the card we have 5 of them. I'm not sure that you need to add 11 of them. Maybe it would be fine to add 8, or maybe even just 6. I don't know. I added 11, and then I went up to 14. 14 definitely doesn't perform, like 14 didn't make any further improvements over 11, but 11 worked great. So doing this, and the thing is, I did this after doing a bunch of other modifications, but before I added these capacitors, card would top out on like the stock voltage at 2820 max clock. And that then went up to 2858. Which is quite the improvement. That's 36 megahertz more. So yeah, that's a pretty big deal. Now, there is one issue with this. I don't know if it's dependent on the existence of all of this. Like, all of these extra multi-layer ceramics that you can see on the output, like, those were there before I did these. And so I don't know that these would be that effective if these weren't already present. So, yeah, also, actually, that's VDDCI, but, like, these. Yeah. So that's the main concern I have with it, is just like I'm not sure if you need the upgraded output filtering before you do the input filtering, or if just doing the input filtering is enough. I would certainly start with the input filtering first and then worrying about the output filter, because the input filtering on these cards is definitely really bad. Like, I wouldn't be surprised if everything I did on the output filter didn't do anything, and it was all just the input filtering upgrade that led to this improvement. But yeah, I don't know, because it's just like the order in which I did the modifications doesn't allow me to know which one is more important, because one came after the other, and then the last modification I did had the most impact, and it's like, well, I don't know if the one earlier was necessary. Because the thing is like, what the input filtering upgrade does is basically when the VRM needs to quickly ramp the output voltage up, when it does that, it pulls a bunch of energy from the input side. And so if the input filtering capacitors discharge too much when there's a big power transient, and the card is ramping up power consumption quickly, then the VRM is just going to run out of sort of energy to push to send to the output quickly, and your output voltage is going to drop. So these won't really be like having a really nice output filter won't do anything if your if there's just not enough energy to supply to the output. So if the input filtering is bad, then your output filtering kind of doesn't really, your output filtering just isn't going to really save you. So I'm not sure. So that's kind of the thing, is like I did all the output filtering modifications and then I did the input filtering. And so it's like, maybe if the input filtering was good, then the output filtering mods would have shown improvements in terms of overclocking. But yeah, the order I did it in, can't tell you if that's possible. If that was important, if that's the case. Now, if I had a card that isn't modified at all, I could compare. Well, actually, no, I'd need a card with just input filtering on it and no output. Then I could do a comparison. But oh well, too late for that. Oh yeah, so the input filter led to a nice improvement from 2022 to 2058. And the interesting thing with and other than that, it also reduced the amount of coil whine the card produces. If I use the silent BIOS, it's completely silent. Like, there's no coil whine on the silent BIOS whatsoever. On the without a power limit and no overclocking, there's a bit of coil whine, but it's nowhere near as loud as it used to be. Like, it used to be the coil whine was very clearly louder than the fans on the card. Now, if you listen for it, it's still there, but it's not way above everything else. So yeah, the input filtering also reduced the coil whine, which wasn't even what I was aiming for. That was just kind of oh, neat. The card's less noisy than it used to be. Anyway, so yeah, this I think was a good idea. Now the funny thing is you can actually get cards with better input filtering from the factory. There's the ASRock OC formula and there's the MSI Gaming X or Gaming Z. They both have much more input filtering capacitance than basically any other 6900 XT. And so those, you won't need, this modification is completely pointless on those because they come with this kind of capacitor configuration from the factory. So yeah, they come with a better input filter from the factory and it works great. So good job ASRock and MSI for not just stretching out the reference PCB like basically everybody else does. Now the coil whine thing can also just depend on which inductors you're using. If we look at the thing is the coil whine on my card is caused by these two inductors right here, which is why upgrading the input filtering, increasing the amount of input filtering capacitance reduces the coil whine. But the thing is, there's also cards that just use different input inductors that might whine less. I don't know. I only have one 6900 XT, and that's this one. But yeah, at least on my card, the extra capacitors reduce the input filtering. Reduce the extra input filtering capacitors reduce the coil whine a bit. They did not, yeah, they reduced the coil whine. It's not completely gone, except at lower power settings. Anyway, other than that, I also stole basically all of the all the larger multi-layer ceramics from the input filter of an RX Vega. That would be these and these. So that is a 1 microfarad capacitor. Now, because I stole them from an RX Vega, I don't know their exact specs, but it is 0805 package size. And it is, like, I'm going to guess it's like 25 or 35 volts. Maybe 30, but yeah, somewhere in this voltage range. And you might be like, why is it rated so high when it's on 12 volts, right? Like 16 volt capacitor on 12 volts, that makes sense. But why would you use like a 25 or a 35 volt capacitor on the 12 volt, like the 12 volt side of the VRM? And the reason for this is the multilayer ceramics, they lose capacitance based on how much voltage is applied to them. So if you have like a 1 microfarad capacitor that's rated for 16 volts, a lot of them will lose like 80% of their capacitance at 12 volts. So they're basically they basically disappear. And so, whereas if you use something that's rated for like 25 or 35 volts, they can lose like 60 to 70%. Like they're not going to lose as much capacitance. So yeah, but you're going to have to check this per capacitor because it's not like as far as I'm aware, it's not like a universal rule that a 25 volt capacitor loses 60% and a 16 volt capacitor loses 80%. Like it depends on the specific model and a bunch of other things. But yeah, like I wish I don't know what the original spec was that AMD used, but I would assume they wanted some that didn't lose a bunch of capacitance when 12 volts is applied to them. So if I was like looking to buy 1 microfarad 0805s, I'd be looking somewhere in the 25 to 35 volt range. Now, these larger ones, these are 10 microfarads and 1206 package size. And same deal on the voltage. You're going to want 25 or 25 or 35 volts. And in terms of temperature for all of these, I think they might be X7R. But basically you want them to be at least up to 105 degrees Celsius. You don't want them to be less than 105 degrees Celsius because these are sitting directly behind the power stages. So if the VRM and, VRMs are perfectly capable of running very, very, very hot. So you don't want to be using a capacitor that has a maximum operating temperature of 85 degrees directly behind a VRM. And really you would probably want to use a capacitor that's rated for, well, at least 105, if not 125, right? So yeah, I wish I knew the specs for these, but I stole them off of Vega. So the only thing that I could do is I could measure that they have 1 microfarad and 10 microfarads of capacitance. And I'm guessing that they're 25 or 35 volts because they have to tolerate at least 12, right? Like they're on the input. They have to tolerate 12 volts. They could be 16, but I'm not sure. Anyway, so yeah, I added all of the I just added basically almost one per phase, except here because there's a via right there that scared me off from doing this. But as you can see, we have bam, 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 bam. Every single one of these, you can see one there. Then I didn't do this one because screw hole. And then we have the 10 microfarad ones. And I had an extra 10 microfarad one left over because the Vega just had more input filtering capacitor, like more of these than I needed. So I added an extra one over here. And we have all of these, right? Just going up the board like that. So that's that. And these also led to an improvement. In fact, the act of stealing the input filtering capacitors from a Vega is what made me notice that, wait a minute, upgrading the input filtering leads to better core clocks. I think, if I remember correctly, I think the card was initially doing 2809, and then it went up to 2822, and then I put the big bulk capacitors on the input, and it got all the way up to 2858. I'm not sure that the multilayer ceramics were actually necessary, because I'm not sure if it was just the act of adding a bunch of extra capacitance that made the effect, or if it was also the fact that these are low ESR, low ESL capacitors compared to these. Well, lower ESR. They're not massively different from 8 milli, they're not massively lower than 8 milliohms, but yeah, so that's kind of that. So those, and I also did those on the other side, right? You can see the same here, and then, right. there, and you can see I skipped this one because we have this connector over here. Skipped this one because, again, the connector's in the way. Then this one is a 1 microfarad because the gap between these capacitors is much smaller than, like, here or here, right? Like, you can see how these are much closer together, so I didn't want to use the 1206s there, so I moved one of the 1206s here. So that's all the input filtering upgrades I did, and those definitely led to just more, like, those, you know, made the card clock the core higher. At this point, the card does 2858 on air cooling, which is way higher than what I was able to run when I first got it. So, yeah, I'd say the input filtering upgrades, and also there's the coil whine reduction, which was just kind of like, don't really care, but that's a thing that happened. So yeah, the core clock improvement, like, that really surprised me, but at the same time, it was like if you compare the input filter of like a Vega to a 6900 XT, the 6900 XT looks absolutely horrendous. If you compare the input filter of a 6700 XT, the 6900 XT still looks pretty bad. So yeah, anyway, so this was like a good idea. Now, the only issue is I don't know, like, and I mentioned this earlier, I don't know if the input filtering upgrades would have been this effective if I hadn't already, like, gone completely insane on the output. So on the output, okay, this is VDDCI here, and we talked about VDDCI you don't have to worry about. But from here to here, it's all VCore. And from here to here, it's all VCore. And then there's a bunch of stuff down here which you don't have to worry about. We'll get to the connector. Also, I need a drink of water. Anyway, so as you can see, I've added a lot of capacitors, and these are just more of the same 22 microfarad 0603s that I used on the front. So we're just going to flip this over, and yeah, it's just more of these. And let's count them, because I really want to know how many I added, because I've just kind of like these basically got onto the card in a sort of like, well, I'm bored, let's add some capacitors kind of manner, and I get bored pretty easily. So anyway, we've got 2, 4, 6, 9, 11, 14, 16, 19, oh boy, 22, 23, 26, 28, 28, what is that, 31? Oh man, 33, 34, 35, 36, 37. Oh boy. Okay. I think I did. Okay, that's 37 on this side. Oh man. And then we've got 3, 4, so that's 7, 8. Oh no. 11, 13, 15, 17, 18, 20. Oh no, oh man, okay, so we've got 20 on this side, 37 on that side. Okay, there's over 100 extra multi-layer ceramics capacity. This is the most cap-modded card I've ever had. Without a doubt. I've never put this many capacitors on the card. Well, the thing is, if I put this many capacitors on most of the other cards that I've bothered to mod, there'd be more, like, the cost of the capacitors would be significantly starting to exceed the cost of the card. This thing's 1,800 quid. It's not going to happen anytime soon. So that's 57. There is 66 22 microfarad capacitor. I should add 3 more, you know, just to get it up to 69. Yeah, so there's 66 of those. Damn. Anyway, other than that, I also added these 470 microfarad Panasonics, again 3 milliohm ESR. This didn't do anything. I added these after the input filtering upgrades, and yeah, they just didn't really do anything, and took way too much effort to add. The thing is, I'm not sure if these are going, like, after all the multi-layer ceramics, so there's a decent chance that, like, any other capacitor type is just not going to make a difference at this point. Fun fact, there are old GPUs where they had only multi-layer ceramic output filters. No polymers whatsoever. The reason they don't do that anymore is that normally you need so much capacitance that if you did that, it would just cost way too much. Like you'd need for every one of the, like if you wanted to replace all of these polymers with multi-layer ceramics, you would need like 1047 microfarad multi-layer ceramics per polymer, which would be very, 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 very expensive and also take way too much time because there's how many of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, so with 14 of them, you'd need 47 microfarad multi-layer ceramics, which, especially considering there's a bit of a capacitor shortage right now, or just general electronics shortage, bad idea. You don't want to be doing that. Anyway, yeah, so I added way too many 22 microfarad 0603s to the output of the vCore VRM, and I don't even know if they did anything because the card just clocked the same until I did the input filtering stuff. So yeah, that's kind of frustrating. I'd love, like, at this point, I'd love to have a second card to, like, go, like, try a different mix of mods or, like, try a different order. Like, I'm really unhappy, like, with the multi-layer ceramics is just, like, it takes too much effort. Like, I'm wondering if it would have been possible to achieve the same effect with just, like, a couple polymers or something, or if the multi-layer ceramics are even necessary. They might not be, right? I don't know because I did them before I did the input filtering upgrades. But yeah, so sort of all of the cap modding I did to vCore, and then there's this stuff which, well, like you can see there's some 22s thrown in. This 470 microfarad came, that's a 470 over there. You don't need to bother with this as far as I'm concerned. It doesn't do anything. And then over here we have the header for the Elmore EVC2, and is this going to open? Okay, well, we're just going to go over to, oh boy, there's too many tabs. Close all the tabs. The thing is, I just want to go to Elmore's, Elmore Labs, there we go. Because, nope. Yeah, so you get this, and it comes with all the headers included. And this is how you get voltage control on the 6900 XT, is you buy one of these. So anyway, back to the card, and then you take one of the little accessory, like the little headers that it comes with, and you just solder it right here, because there's there's an I2C header down here. And this top pin is ground. So this one right there, that's ground. And then the rest of them, you just match the order that they're on the EVC. So, yeah, that's how you hook up the EVC, and then you get voltage control for vCore, memory controller, and SoC. So you get all 4 main voltage rails. The only rails you don't get is you don't get control of this, and you don't get control of that. And the only way to get control of those is with like a hard mod, which technically the EVC will do even those, because it has it has the ability to do feedback mods built in. I still personally prefer potentiometers because you can just stick them somewhere on the card. Especially on a card like this, you have plenty of space, like in this area and, well, mostly this area, which you could stick one or actually maybe even 2 potentiometers right there. So, yeah. And though I'm not sure if this is even necessary, like this is 1.8 volts, this will primarily powers the BIOS chips and a supporting rail for the memory. Generally this doesn't do anything. There's maybe a chance that, like, maybe if the BIOS chip is getting too cold when on LN2, but that's not really a thing. The BIOS chip on most GPUs is really close to the GPU core, and it's not really like a real issue that you run into. Now, this rail, on the other hand, that's the one I'd be most wondering about, like, is modding that one worth it for LN2 overclocking? Maybe even at ambient it might do something. But yeah, that one also, like, you need to do a hard mod, and it's just like it's just awkward because you're gonna have to run like a wire or something like that. And unfortunately, the chips in charge of those rails are really like quite fun. Well, we'll see. Like, I'll have to look into that. I've not yet done that on my card. That's probably going to be the like next modification I do to mine. But yeah. We'll talk about it if that's significant when I do it. So yeah, that's the mods that I've done to my RX 6900 XT Red Devil Ultimate. The input filtering, I'd say, definitely worth it. The extra the extra memory filtering, also worth it. The extra V-core, I have no idea. Yeah, I have no idea. I just straight up no idea if that does anything. There's a decent chance that the card was just because at least on paper, the stock output filter here doesn't look bad. You've got 14 SMD polymer, 470 microfarad capacitors, so they're going to have, like, the ones Power Color is using, they're from APAC, so they're not going to be the 3 milliohm ESR Panasonics that I like to use, but they're still not going to be anywhere near as bad as, like, through-hole polymers. And even, like, relatively high ESR SMD polymers just are still really good capacitors. So, for output filtering like this. So, yeah, like, there's 14 of those. I don't really think that would be too much of an issue. And there's a decent amount of, like, I'm not sure if those 0805s that are on the output are 47 microfarads or 22 or whatever, but they're probably not that low capacitance either. And then, of course, you have the absolute sea of 0402 multi-layer ceramics directly behind the core, which I have no idea what capacitance any of those have either. But yeah, I don't like the output filtering on these cards. Doesn't look bad, at least not on paper. It looks very similar to what you'd see like on a Vega or something, and so, and the output filtering on Vega is great. There is no room, like, you're not gonna do much in terms of upgrade. Like, in terms of cap mods on Vega, you're basically wasting your time. The input filter on this is garbage. Which you can just kind of tell from the fact that, like, the stock input filter is a grand total of, like, the bulk capacitance for the stock input filter is a grand total of 100, like, these aren't even that big. These are 180 microfarads each, right? So that's kind of the thing. So yeah, the input filtering upgrade's worth it. And this sort of explains why. The output filtering for V-Core, I don't think so. Memory, yes. Memory, I think, was worth it, because the memory clocks better on my card than it ever did when I first had it. Like, I can bench 2180, which previously was just like when I first got the card, that was like, no. Like, 2180, you were just losing so much performance. So yeah, that's kind of it. Hopefully, like I'd love to talk to somebody else who'd like I'd love to see other people try, like, different capacitor configurations. I get that, like, this is a really expensive card. So, you don't want to break the card. And like I think cap mods are easy, but the thing is, I've done a lot of cap mods. So, you probably want to practice on something cheaper first. I highly recommend 600 series reference NVIDIA cards, because those are trash. Actually, yeah, old reference NVIDIA cards are just like, a lot of them are universally garbage, both especially in terms of output filtering. Input filtering is generally pretty good. Like, that's the crazy thing. This is, like, the first card I've come across where it's like, oh, the input filter really needed an upgrade. Whereas in my past experience, it's like, input filtering is a waste of time, and you should just not bother with it. Yeah, like, even, like, old NVIDIA reference cards, like, NVIDIA will generally have a pretty solid input filter. The output filter, on the other hand, is depends on which exact model, but a lot of them are like downcosted to the absolute bare minimum. And then the same goes for the power stages on a lot of those cards. So yeah, but yeah, that's kind of the thing. I'd love to basically I'd love to have more information, right? Like I'm annoyed that basically it's only very recently that I figured out how to run the card at like static voltage. So I don't even have like oscilloscope measurements from like before and after that I can use for comparisons for VCore. For memory and the other rails I do, but for VCore I have nothing because I didn't figure out how to get the card to run static volts yet. Yeah, so that's super annoying. But you know, a lot of these modifications seem to have worked. I mean, I was hoping so, like, yeah, well, I wouldn't do them if I didn't hope for them for some, at least some of them to work, right? Like that's kind of the thing is like I don't like yeah, like I wouldn't do well, there are definitely cards where I've done mods and it just does nothing. Which is always like like especially if you're working on something like a lightning card, like older lightning cards and like oh yeah, like there's GPUs which like they come from the factory with these mods, right? Like again, there's the ASRock OC formula. It has an upgraded input filter. I wonder why that would be. There's also the MSI Gaming X. It's like, and that card goes to town on also the output filtering in terms of just total capacitance. The capacitor choice, or the selection of capacitors that MSI used on that card, I'm not necessarily a huge fan of, but the actual just sheer capacitance that they added to the output, yeah, is a lot. It's like way more than reference, and then the input is just a massive upgrade as well. So yeah, it's like there's cards that do this from the factory. This is not one of them. Even though this is definitely one of the most expensive, like well, all of the 6900 XTs are expensive. This is just not one of the cheaper ones. So yeah, that's it for the video. So I guess thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both the Patreon and Teespring help out immensely with running the channel because it allows me to do things like buy a 6900 XT and then buy all of the capacitors that I ended up attaching to it, as well as all of the soldering equipment for doing these kinds of modifications faster. Because the thing is, I was capable, like, doing this kind of, these kinds of cap mods, I was capable of doing that with, like, my really crappy soldering iron and a toast. Well, yeah, honestly, even just with the very crappy soldering iron, most of this would have been doable. It wouldn't have been very fun. It would have been way uglier. There'd be way more blobby, like, the solder would be blobbier. But, yeah, yeah, so if you'd like to support the channel, there's links for that down in the description below. It would be much appreciated if you check them out. And that's it for the video. Thank you for watching, and goodbye.